Hello friends, welcome to my YouTube channel AJElectrical. My name is James Kutti Thomas, retired electrical inspector from Kerala. Today the topic of the video is the third part of earthing configuration. Through the first two parts I have given some basic terms and also explained about the notations using for this earthing configuration. Today we are starting with the TN system, which are the different subsections of TN system, etc. Okay, let us move to the topic. Let us see what is TN system. Means see TN. Means there are two letters T and N. The first letter is representing the source, means T, means source is earthed. Source is not unearthed. So in TN system, any single point in the source will be earthed. Usually the source means it can be the secondary of the transformer can be a star connection, and the star connected point will be earthed, and that is what is called the neutral, or the star point is called neutral, and this neutral or the earthed neutral or the grounded neutral is fed to the installation of the equipment. Okay, I think that point is clear. See here I have taken the neutral as our reference. So neutral means in a balanced system the neutral current will be 0, and in a unbalanced system the current will not be 0, and there will be some zero sequence current. Anyway, here I am taking the neutral as reference, and because of this zero sequence current or because of this neutral reference, this TN system is also called as zero protection system. See here we are taking the neutral or the grounded neutral from the source to the equipment or the installation. So there are two factors. One is neutral and the other one is grounded conductor. So there can be two conductors, neutral conductor and the ground conductor or the protective earthed conductor from the source to the equipment side. See here in TN system, what's the meaning? There will be neutral and protective earthing taken from the source to the equipment or the installation. So there are different methods for taking these two neutral and protective earth conductor. Either it can be run separately, or it can be run through the single conductor, or like that there are three different methods. That is I explained here. See, please note these three diagrams. See, in each of the diagrams there are three equipments. Why I took three equipments for this explanation? Because in our standard 732 and 3043, only one equipment is taken for the diagrams. But I felt some confusions. That is why I took three individual equipments of the same installation. See, please note the this color codes I have used. The violet color is given for pen conductor, and blue is given for neutral, and green protective earthing conductor. Let us see what the first configuration of TN system. It is TNS. S means separate. Separate means the neutral and protective conductor will be separate from the source to the installation. That is why we call it as TNS. And please note here the three equipments. Each of the neutral and protective earthing are given separately. See, in the next case, it is TNCS. C means combined. See, up to the point of commencement of supply, means the supply is from the source to the installation, and up to the point of commencement of supply, that portion is called distribution. So for this distribution part, the neutral and protective earthing will be combined, and it is called pen conductor, means a protective earthed neutral. It will be a single conductor having two functions, neutral and protective conductor. At the point of commencement of supply, this pen conductor will be divided into two, neutral and earth. See here the blue color and green color, N and P, means that installation is having neutral common and earth common. Is it there? TNCS, that's why it is called TNCS, means C means combined in the distribution part and separate in the utilization part or the installation. So next is TNC, C means combined, means the neutral and protective conductor will be combined throughout the system. Please note this violet color throughout the system is it is violet or the protective earth neutral, and for the even inside the installation it is the same conductor. That is why we call it as throughout the system the conductor will be combined or it will be pen conductor. But when it is splitted, it is reaching to the equipment of the installation. See, equipment 1, it is getting the pen conductor. At the equipment terminal, it will be divided into neutral and earth. Means that installation is not having a common neutral conductor or a common earth conductors. That's the difficulty here in engaging an RCCB in this type of connection. Otherwise, we can provide RCCB for each of the equipment. That's a difficulty here. Anyway, we will study it in detail later. Okay. Here I have one more point to add. I told you TN system is also called as zero protection system. See, there are two conductors, neutral and the protective earth. Neutral is also called as working zero line, and the protective conductor or the protective earthing conductor is called as protection zero line. I think already you got the idea why the word zero is there. See, here in TN system, neutral is also called as working zero line, and the earth conductor is called protection zero line. Okay, now let us move to TNS system. What is TNS? I already given you a basic idea about TN system. Here the neutral and protective conductor will be separate from the source to the load. See here, system having separate neutral and protective conductor, and consider a 7-storied building or a multi-storied building. See, it may be having a transformer, and the metering will be LT connections. So from the transformer, the neutral will be earthed, and from that point itself we will be taking neutral and earthing separately. So even in case of an industry, it is very suitable for in the same purpose. But the industry means this type of connection is suitable only if the industry is having a limited area. So, suppose the industry is having a distributed area, and it is having some equipment in a remote area. In such cases, this TNS is not suitable. Okay, and here you can see the equipment body is connected to protective earthing conductor, means the exposed conductive parts of the insulation are connected to protective conductor via MET of the installation. Okay, in the last video I already told you about MET insulation, means it is just like an earth bus interlinking all the earth, all the metal parts, just like equipotential bonding. Then let us see some more specialities of this TNS system. See, in TNS system, in normal cases the neutral will not have current. So, but in unbalanced current or in an unbalanced system, the working zero line will have some current. But the protective earthing conductor or the PE conductor will not have current. Means the neutral will have current, but the protective earthing conductor will not have current. So it is actually it is safe. Means the protective earthing conductor is not having any current, and it is safe and reliable. Means TNS is safe and reliable. Then this neutral is taken only for single phase circuits. Then another thing, the special protection line P is not allowed to break the line, nor can it enter the leakage switch. Actually, this neutral as well as the protective earthing conductor should not have any break or any switches. Means if it is broken, the neutral conductor or the protective conductor is broken, it will affect the protection of the whole system. That's why it is mentioned there. Then this type of system is suitable to provide this RCCB in the system. Then if the leakage protector is used on L line, the working zero line must not be grounded repeatedly, and the PE line has repeated grounding. Here actually in this installation we will not earth this neutral repeatedly. Means in the starting point or the source end only we will be earthing the neutral. After that the neutral will not be earthed, but the protective earthing conductor can have any number of earth electrodes. Why we are not earthing this neutral? Because we are providing some earth leakage or earth fault protection there. If we are repeatedly earthing the neutral, that system will fail. So in short, the neutral should not have any repeated earthing, or there should not be any earthing after the leakage protection device. But the protective earthing can have any number of earth electrodes. So finally, the TNS system is reliable and safe, and for industrial and civil buildings we can use this type of connection. Now let us move to the references. What is said with our references 732 and 3043 about this TNS system? See, in 732, please note these notations very carefully, because in the same standard, in different diagrams, these notations are used in different ways. Anyway, based upon this IS 12032, the exact symbols are like this. This single line is representing line conductor, then protective earthing conductor, then combined pen conductor, then one more neutral conductor. So please by heart these notations for understanding about the diagrams. Okay. Now let us see different connections as per our 732 and 3043 standards. See, here we are dealing with a TNS system. See, in 732, please go through this diagram, and neutral and protective earthing are separate, and for two installations are shown here. In one of the installation, neutral is taken, is not taken. See, here the neutral is not taken. But I think it is not that much confused, and here you can see the earthing in the distribution area. Means the protective earthing must have earthing in the supplier side, in the distribution side, as well as it can have earthing, any number of earthing in the installation side also. That is very much clear, I think, and it is figure 9 with a separate neutral and separate protective conductor. And please come to the 3043 part, and here also it is very clear, and see in the same installation on 3-phase load and single phase load are shown, and for the 3-phase load neutral is not taken, and the single phase connection neutral is taken, and the 3-phase load, or the let it be a 3-phase load or let it be a 3-phase consumer. In both way we can explain, because it is also a little bit confused in different pages of the standard. See, let us let us see it as a 3-phase consumer. It is instructed that each of the 3-phase consumers, means the installations having voltage more than 250 volt, must have their own independent earth electrodes. In the first video I have shown you a related page in from our safety regulation. The 3-phase consumers must have their own earthing individual earth electrodes but the single phase consumers are not compelled to have earth electrodes. Okay, now in the next diagram, see here the secondary winding is delta connector. Means it will not have a star point or neutral point. So any one of the line is earthed. See the figure, it is figure 8, figure 10 in 732 standard, and it is highlighted the line conductor. Means the line L3 is earthed and it is taken from the same point. This protective earthing conductor is also taken to the equipment or the installation. And see here the equipment, I think it is clear, no confusion. And please note these conductor notations. Some mistakes are there throughout the standard. Okay, now in the next diagram, here without any neutral, means in the distribution part there is no neutral. You please see it is a star connected point, but we are taking only the protective earthing and phase conductivity. No neutral connection is taken, and it is a distribution part earthing, and the consumer side also the protective earthing can have any number of earth electrodes. I think today's class is very informative and it was useful to you, and we discussed about the TN system and TNS in detail, and as I told you, TNS is very suitable for buildings having an individual transformer, just like a multi-storied building or an industry with a limited area. And in TNS system we can provide this RCCB also. Then throughout the TNS system we will be providing protective earthing from the source to the equipment. In the future video we will be discussing about TNCS and TNC. Thereafter we will go to TT and IT in detail. Okay, please share this information with your friends. I think for practicing engineers this information is very needy, and please share to them, and please subscribe to my YouTube channel, and please press the bell button also, so that you can get the notifications of the future videos. Thank you for your patient listening. We can see with another video in future. Thank you.